everyone, happy Wednesday. Today's target is to be able to convert the amount and type of ingredients found in cooking recipes. Today we're going to be looking at a recipe on how to make omelets. This recipe calls for 6 eggs, 1 cup of cheese, and 2 omelets. Okay, so effectively what we're going to be doing today is we are going to be taking conversion factors and using those conversion factors to find things in our equation. First things first, let's just write an abbreviated equation since that is step number 1, just like we discussed on Monday. I'm just going to have eggs be EG, because that's kind of like an egg. We're going to have cheese, 1 cup of cheese is just going to be 1C for cheese, and that's going to produce 2 omelets. Okay. So here's my balanced chemical equation. Let's quickly take a little bit of time and identify what conversion factors are in this equation. So I know that if I've got 6 eggs, I can produce 2 omelets. It kind of looks like a 20, so we're just going to make sure to, there we go, 2 omelets. Okay. So 6 eggs is equivalent to 2 omelets. That is a conversion factor. Additionally, I know if I've got 1 cup of cheese, that's going to be enough cheese to make 2 omelets. So that's another conversion factor. Cool. Lastly, I know if I've got 6 eggs, I'm going to need exactly 1 cup of cheese so that I don't have any leftover eggs. So that's a conversion factor as well. 6 eggs, and that is going to be 1C. Cool. All right. These are what we would refer to as mole ratios. Okay. So a mole ratio is just a comparison of 2 numbers that are moles. So what is a mole and how does a mole find its way into these kinds of problems? How do moles impact you and impact your life? Let's think of an example of Halloween. On Halloween, usually people have a big bucket of candy. There's a lot of ways we could measure the amount of candy in that bucket. We could measure it by, the size of the bars, by their volume. We could put the pieces of candy on a triple beam balance and measure their mass. But that's kind of a lot of work. Most people wouldn't want to measure the volume or mass of candy bars. Instead, they're just going to give 1 candy bar to all the trick-or-treaters coming to their house. They're going to give a mole of candy bar. So when I'm saying we've got a mole ratio, I'm saying an egg is the equivalence of a mole. A mole is just kind of an amount or something, like a dozen. A dozen means 12. Or in this case, I'm loosely defining the word mole or making it a synonym for 1 egg or an omelet. 6 moles of egg is equivalent to 2 moles of omelet. That's how those things are molar ratios. And we kind of talked about that a little bit on Monday, but we didn't use the term mole ratios when we were describing how to use these numbers. There are 3 other conversion factors that we could get from this problem. What I could do is I could take my eggs and I could put them on a triple beam balance and I could find the mass. And I could do the exact same thing with a cup of cheese. I could do the exact same thing with 2 omelets. And it just so happens that I actually did. I took a little bit of time to gather a couple more conversion factors. So we know, because I put them on a triple beam balance, that 1 mole of egg is equivalent to 100 grams of egg. We also know that 1 cup of cheese is equivalent to 50 grams of cheese. And we also know that 1 omelet is equivalent to 325 grams of omelet. Sorry that got a little scrunched in there. And the reason that we know these is there's something that I found on a triple beam balance. This is data that you would be provided with in any practice problem. You would know these conversion factors. Now, these conversion factors are very similar to molar mass. So why are those things similar to molar mass, and what is molar mass? For starters, molar mass is what we find on our periodic table of elements. It's in the upper left-hand corner. So if we had a hydrogen atom, upper right-hand corner, hydrogen would have a molar mass of 1.01. Oxygen would have a mass of 15.99, or about 16 grams per mole. And in this particular situation, the molar mass of an egg is 100 grams of egg per 1 mole of egg. That's how those things are our molar masses. I'm going to take a little bit of time and just rearrange the board a little bit, and then we can go over our first problem. Cool. Okay, before getting into this problem, let's take a quick minute and review what we already know. We know the balanced recipe, or the balanced equation for how to create an omelet: 6 eggs, a cup of cheese will make 2 omelets. Cool. We also know 6 different sets of conversion factors, and there are kind of 2 different categories. There are these mole ratios. A ratio is just a comparison of 2 numbers. A mole is just an amount. So this is just comparing one amount of a substance, in this case eggs, to an amount of omelets. Okay, we're comparing one ingredient to another ingredient. It takes 6 eggs to make 2 omelets. A mole, an amount, like an egg or an omelet. Cool. The molar mass is how much mass is in a mole. So if I have 1 egg, that egg has a mass of 100 grams. Because eggs are all about the same mass. They're all about 100 grams. Cool. If I've got 1 cup of cheese, that cup of cheese has a mass of 50 grams. So why are these numbers useful? How could we use these in the kitchen? Well, sometimes we're not told how many cups of cheese we have. Sometimes I like to buy those bricks of cheese, and the brick of cheese says I've got 100 grams of cheese. But that doesn't help me that much. I can't just take 100 grams and put it in here. I need to use my mole ratios to figure out how many cups of cheese I'm going to need, or how many moles of cheese am I going to need. So how do we do that? First things first, once we've kind of set up our problem, once we figured out our balanced chemical equation, that's step number 1, and identified our conversion factors, that's step number 2, now we need to actually set up the problem and identify what we know and what we don't know. Okay, so we know 2 things. We know we've got 100 grams of cheese. There we go. 100 grams of cheese. And we also know the molar mass of cheese. See, we know that 50 grams of cheese is equal to 1 cup. Why am I pointing out that particular ratio? Why do you think that one is so important? Just based off of the units, what's very special about one of the numbers in that ratio? It's the only one which has grams of cheese. And this is how it's always going to work. There's always going to be a bunch of different ratios that you can use, but there's always going to be one ratio that has the unit that you need. We know we've got 50 grams of cheese. So what I can do is I can use that ratio just like we have in the past. I can use this like so. I can put 50 grams of cheese on the bottom because I'll need them to cancel out. And I can put 1 cup of cheese or 1 mole of cheese on the top, because that's the thing that I want to end up finding, cups of cheese. How much cheese do I actually have if I've got 50 grams of cheese? So my grams of cheese, they cancel out, and it's 100 times 1 divided by 50, or 100 divided by 50 is just 2 cups of cheese. Let's do a couple more example problems, because this is a little complicated. So let's just say, instead of 100 grams of cheese, let's say if I have 750 grams of omelet, how many moles of omelet am I going to make here? How many moles of omelet do I have? This problem is very similar to the one I just did. If you're not sure how to do it, rewind 30 seconds and rewatch how I just did the last problem, and then see if you can solve this one. Good luck. Okay, now that you've had a chance to try and solve this problem, let's go over it and see if you're right. So, I have a number that I know. We're always going to start with that number, the number that we know that's given to us in the problem. 750 grams of omelet. Now I need to pick my conversion factor. There's 6 of them. Which one do I need? Well, there's only one that has the units that I have. This one right here, it has grams of omelet. So what I can do is I can multiply my expression by grams of omelet. At least I gotta put those grams of omelet on the bottom, right? Because they need to cancel out. And I can put 1 omelet on the top, because that's the unit that I want. How many omelets will I make? So my grams of omelets, they cancel out. 750 times 1 divided by 325. You could put that in a calculator, and you would get 2 omelets. Cool. All right, so let's try and do a couple of problems in reverse. Let's say this time we know we have 18 eggs. I went to the grocery store, got one of those special value packs with like 18 eggs in it. None of them were cracked. It was great. And I know how many moles I have, right? I have 18 eggs, or 18 moles of egg. But how many grams do I have? Sometimes recipes will ask for that. Sometimes they'll ask, we need 420 grams of powdered egg, or 500 grams of flour, or something like that. So how could we convert moles into grams? Well, what we need to do is, just like before, we take the number that we were originally given, 18 moles of egg, or 18 eggs, whichever makes the most sense to you. And I need to find the grams of egg. So this can be a little tricky, because there are 3 different ratios that have EG in it. So which one do I actually want? Well, to figure that out, we need to look at our unknown. See, we don't know how many grams of EG we're going to have if we get 18 eggs. So we need to figure out the grams of EG this time. We're doing the reverse of what we just did in the previous 2 problems. So once again, I'm going to use my molar mass. See, molar masses are really useful for converting grams to moles and moles to grams. Okay, so we've got 18 eggs. And what we're going to do is we're going to put 1 EG, 1 egg, 1 mole of egg on the bottom, and 100 grams of egg on the top, because we want our eggs to cancel out. So it's going to be 18 times 100 grams of EG, or 1,800 grams of EG. Which is a lot of grams. It's a significant quantity of eggs. Okay. One question that's worth asking is, why, Mr. Hempstead, why does this matter? Why do I care if 18 eggs is the same as 180 or 1,800 grams of eggs? It's not about the individual problem, it's about the process. It's how you get there. This mathematical concept can be applied to so many different avenues. I can use conversion factors not just in cooking, not just in school, but in just about everything. In finance, in construction, in medicine, in just doing your taxes, we use conversion factors all the time. Knowing how to use conversion factors is a really useful tool that will help you out in life, no matter who you are, no matter where you go. Okay. We're going to do a couple more practice problems. So let's just say, for example, that I'm going to tell you, you guys have 3 cups of cheese. You've got 3 cups of cheese. And I want to know how many grams of C are present. See if you can solve this problem. Good luck. Now that you've had an opportunity to solve this problem, let's see if you're right. So we've got 3 cups of C. That's the number that we're given, 3C. And we know that we need to figure out the grams of C. That's our unknown, the thing that we're trying to find. So we're going to use 1 cup of C is equivalent to 50 grams of C, right? Because they're the same amount. If I took a cup of C and I put it on a triple beam balance, it would have a mass of 50 grams. So I'm going to put the 50 grams of C on the top, and I'm going to put the 1C on the bottom, because I need those to cancel out. 3 times 50 divided by 1 is 150 grams of cheese. So if I have 3 cups of cheese, I've got 150 grams of cheese. Cool. 2 more problems that I want to go over. This time, let's say we've got 4 cups of cheese. But instead of wanting to know how many grams of cheese I have, I want to know how many eggs do I need to use all my cheese. Okay. So how many eggs do we need to use all of the cheese? So you'll notice this time around, I'm not asking about grams. I'm just asking about the unit cheese and egg, a mole, an amount of it, right? An egg is like an amount of egg, and a cup of cheese is like a cup. It's like an amount of cheese. So when I've got not grams, but just an amount of something, an amount of something else, that's like comparing 2 sets of moles. That's what a mole is. It's just an amount. So I can use these ratios. Okay. Which ratio do you think I want to use in this problem? So the one that I want to use is 1 cup of cheese is equivalent to 6 eggs, because I know how much cheese I've got and I know how many eggs I've got, and that's what's in this ratio right here. All right, so let's set up the problem. As always, there's a number I am given, 4 cups of cheese. And we know we want to use this conversion factor because it has the units we are using. So we're going to put 1 cup of cheese on the bottom, so those units cancel out. We're going to put 6 eggs on top, because those are the units we want. 4 times 6 divided by 1 would be 24 eggs. This is a super handy trick. Let's say, and you guys do it, you will do it. If you don't right now, you'll do it all the time. If you know you need to have like 8 omelets or something like that, and you've got 4 cups of cheese, you're just going to do this math to figure out, okay, I need 24 eggs. You may not write out the work like we're doing now, but when you're going to the grocery store, you'll need to double or triple or quadruple recipes, and so you'll need to do the same thing with the ingredients as well. Okay. Plus, this is super valuable in terms of teaching us how to do stoichiometry. So, 2 birds, 1 stone. Okay, one more problem. Let's say I'm telling you how many eggs we have. So let's say I have 12 eggs. Just went to the grocery store, paid like 89 cents, got myself a dozen eggs. I want to know how many omelets I can make. Assuming I've got enough cheese, right? Assuming I'm not going to run out of cheese or anything like that. But if I have 12 eggs, how many omelets can I make, assuming I have extra cheese or an excess amount of cheese? Nice. See if you can solve this problem. Good luck. All right. So, most of you have probably figured out we're just going to start with the number we know. We know we've got 12 eggs. And what we're trying to find is the number of omelets that we're going to have in this particular batch of with our 12 eggs, right? So once again, I'm not comparing grams at all. There's no grams. The word gram never appears anywhere in this question. I'm comparing an amount in moles or an amount in omelets to an amount in eggs. Omelets and eggs, those are my units. So I'm just going to use the conversion factor that has the amount of eggs and the amount of omelets. 6 eggs to 2 omelets. So what I can do is I can put 6 eggs on the bottom. I can put 2 omelets on the top. My eggs cancel out. 12 times 2 is 24, divided by 6 is 4 omelets. Which I know kind of looks like 4. I'll try and make it, it's hard to make O's and zeros look different. 4, the trick is you need like a little space. There we go. 4 omelets, right? If I have 12 eggs, I can make 4 omelets. Really useful math if you've got 4 people at your house and you need to make 4 omelets and you're trying to figure out how many eggs you need. Also helpful in stoichiometry. Heck, they're the same thing. So, it's a lot of stuff today. A lot of writing. We're going to practice this a little bit more tomorrow, and Friday will be a work day. So, don't worry if this seems like a lot. It is. We're going to keep on practicing it. We're going to go nice and slow and steady. The tortoise won the race after all. So don't worry if you're not quite at this target yet. We're going to continue practicing with s'mores on Thursday. So talk to you guys then. Thanks. Bye.